Hi everyone, my name is Grace Maurer,
And I'm Casey Miller.
and we're doing a research project on the effect of salinity on development in the green sea urchin, Lytechinus variegatus. So a little bit of background is we want to look at the overall broad picture of what is happening with climate change and its effects on creatures in the ocean. And the reason we chose Lytechinus was because they are a really great indicator species of what could be happening to other species in our oceans. So, as we see an increase in the amount of greenhouse gases, such as carbon dioxide and water vapor, going up into our atmosphere, it is serving as a blanket to trap in more heat on the Earth's surface. As we're seeing more and more heat, this will cause rises in temperature, changes in rainfall, and changes in storm intensity. And specifically, where Lytechinus is found in the Gulf, we are seeing more and more rainfall happening, which is lowering the salinities. And because Lytechinus has a very narrow range into which it can survive, we want to test and see the effects as they go outside of that range, or specifically even lower than the range they're meant to be in. How is this affecting them, and what could we potentially be seeing in the future?
Yes. And to test these effects, we are putting sea urchin larvae in 6 different salinity treatments ranging from 25 parts per thousand salinity all the way to 35 parts per thousand. And from those 6 treatments, we're looking at survivorship of the larvae and we're taking arm measurements. And from those 6 treatments, we narrowed down the salinity to 27 parts per thousand to 32 parts per thousand for the rest of our experiments. And then for those, we were looking at the development, abnormalities seen, and taking more arm measurements. And in figure 1, as you can see on the y-axis, we have the percentage of larvae that are alive, and on the x-axis, the number of days that we looked at. And you can see that it shows support for our hypothesis with the lower salinity ranges dropping off and dying more rapidly than the higher salinities. Most notably, the 20 parts per thousand, all of the larvae died off at 2 days. And then the next one that died off was the 25 parts per thousand. And then if you go to figure 2, with the y-axis being the ratio of left to right arm and the salinity treatments being on the x-axis, anything above 1 means that the left arm is longer than the right arm, and anything under 1 means that the right arm is longer than the left.
And then in figure 3, we measured our abnormality counts. So on our x-axis, we can see our time in hours. We grouped it into a 0 to 24-hour time mark and a 24 to 96-hour time mark. And overall, you can see by our percentage of larvae that we have on our x-axis or our y-axis, we have an increase in the amount between the 3 groups. So after that 24-hour mark, we are seeing more and more abnormalities occurring. And then in figure 4, we actually took these abnormalities and split them up and defined what was actually happening. So on our x-axis, we have our percentage of our abnormality type over the total amount of abnormalities seen for each treatment group. That is on our y-axis. So we have on our base here the different abnormalities and images of each of them. So we have one arm, uneven arms, fused arms, 5 arms, wide arms, and angled arms. And these are all very different. And you can see what a normal larvae is supposed to look like over here in our methods. And one trend we can sort of see a little bit of is that there is a higher amount of these uneven arms, especially in the 25 parts per thousand versus none really being seen in the 32 parts per thousand.
Yes, and so overall, so far in our research, we are seeing that lower salinities do, in fact, have an effect on the development of sea urchin larvae.